Next talk is experimental results with 5G SA and Open RAN network for mission critical applications. SA is standalone, right? Yeah, so I'd like to introduce Dr. Rajeev Gopal briefly. So he is in the executive leadership for net-centric innovation space, cyber cognitive domains, Hughes networks, and he has been a frequent speaker in many of our IEEE conference, including the NextG Summit and other 5G workshop in the past. I'd like to thank you for that. So he's currently the Vice President of Advanced Programs, responsible for resilient communication, LEO 5G, STSA IML. He also has distinguished leadership in the past. He leads the Hughes 5G initiative for US government and was the system design team, OneWeb LEO broadband network using 4G, 5G as the lead for that. He has also earlier served as the network systems engineering and transformational satellite space segment, among others. He was the chief architect, software manager for Spaceway, network operation control center. With that, let's welcome Dr. Rajeev Gopal. And I have your PDF slide. You're going to use that? Okay. So let me stop sharing that and get the PDF up. Okay, I have your PDF. Let me just share that. All right, this is the one. Yeah. Coming up. All right. Make sure I have it ready for you. Okay. It's all yours now. Yeah, I think it's full screen, right? There's something happening there. Alt L, Control M. All right. Yeah, this is better. Okay. All right.
The arrow keyboard.
Yeah, just up and down. Yeah.
Okay.
All right. Thanks.
Thank you. Thank you.
Right.
Well, good morning here and good afternoon, good evening elsewhere in the world. So I'm really happy to be here. Open RAN is a journey and probably started 5 years ago. I was not there at that time. I was busy designing detailed design for OneWeb system. But OneWeb was using at that time 4G, 5G standards, and we were basically creating an eNode B, highly scalable with the 20,000 handovers per second because it was being used for satellite LEO constellation. So that's how I got a little bit more involved with the 4G side. I worked initially in Thuraya system, which was based on 2G. So we have come a long way, and Open RAN probably is the first solid initiative, which is opening up the cellular industry. And I work for Hughes, and our sister company is Dish. So Hughes has a focus, prime interest in enterprise 5G, and Dish, of course, is the largest macro consumer provider, which is using Open RAN and 5G in a very greenfield way. So what I'm sharing today is based on what we started 2 years ago to build a standalone 5G standalone network for mission critical applications, which also uses Open RAN. And the customer, of course, they were driven by 5G, and Open RAN we sort of injected in the discussion. And when we were analyzing the architectural approach, then we, of course, became familiar with the challenges. And when we look at any complex technology, I mean, this is not IT application, this is not web services or databases where we have large number of companies, thousands and thousands of programmers who are familiar with. If you look at traditional cellular technology, it is run by very large companies, both from the provider side and the technology development side. So now we are opening it up so that the smaller companies, innovative companies, smaller operators, private network providers, they can get into action. So this is a massive transformation. And I'm just like providing some data points with respect to our own journey in creating a private enterprise network for a small number of users, but for very mission critical use cases. So security, operations, management, those are the key items which needed to be handled. So again, we had excellent talks earlier today, and we saw how AI ML could be used. We saw the interoperability challenges and solutions. There are a lot of good standards in Open RAN already in place. But when you look at opening up RAN, where especially the real-time orchestration and intelligent control, that's not a easy thing. I mean, trying to divide the modem into two parts and expecting that multiple companies will be able to provide these parts and it'll all work very well. So that's a challenge. And again, I believe that the first tier low-hanging fruits have been plugged. The primary objectives, the primary implementations, they are there. You have plug and play. And now we are getting into maybe second tier or third tier optimization, so which is good. So that's why I've used the word that it's a journey. So this network, it is being used to modernize a flight operation. And these are mission critical use cases. So these are the jet planes, which are used for sensing, which are used for defense applications. And the idea is that once you have 5G connectivity in hangars and in the flight line, then anything and everything you can think of with respect to how the planes need to be fueled, how they need to be repaired, how the diagnostics should happen, all that can be revolutionized if you have very high data rate connectivity and low latency application access. So there are dozens of use cases or applications which get enabled because of this 5G network. So we created a complete architecture. And again, when you look at traditional 5G, 4G networks, I mean, they are being run by companies which have hundreds of millions of customers or tens of millions of customers. And here we are talking about a base which has probably thousands of people, and maybe a subset of that user population would be using this network. So we are bringing down the size of the network, and definitely the customer would expect that the price cost also is a lot less. But when you look at the functions, the features, it is second to none. It has exactly the same features and functions which a company like Verizon or AT&T would provide to very large number of customers. So that's the challenge, how to scale down, not to scale up, how to scale down these cellular networks so that we can benefit from a low latency, high data rates, economies of scale for private networks. And our journey essentially is aligned with that, is scaling down of these highly capable network and associations. So when we look at 5G, of course, we have RAN, we have core, we have multi-access edge compute, and then we also added a local network operations capability, an NMS, and a local security operations capability. And being a SATCOM company, we also added with satellites.
Ja, selvfølgelig.
So I think there is an open mic, so I would request, please check your open mic. Thank you. So requirements were very straightforward. And as I said, that the customer was driven by using the network. Now, how the network is implemented. They absolutely had heard about 5G, a very well-educated customer with respect to the capabilities of 5G. But they did not get into Open RAN that architected in this fashion. We injected Open RAN because we believe that scaling down would be a lot easier if smaller companies are involved. And of course, larger companies have their own role to play. There are some of the very large companies. They are doing wonderfully well with respect to private networks. But the point I'm making is that when you have an active, evolving landscape with respect to private networks, then there are a lot of innovative companies, whether they are from the testing side or design side or RAN side or core side, they can play in this arena now. And this is all possible because of Open RAN type initiatives. So the requirements are very straightforward: high data rate, low latency, and provide good coverage. And we essentially came up with an architecture, and we went beyond 5G, as I said, injected a standalone, injected Open RAN, local NMS, network management, local security management, and range extension with SATCOM. We moved fast, and we truly used DevOps, so continuous integration, continuous deployment. Our program started about a little bit less than 2 years ago, I think in October of 2021. And in February, we did a PDR, and we showed the network in operation in our lab. We had the right partners for RAN, for core, and we brought the customer and say, look, this is our design, and this is what the network would look like. And we gave them a phone to use it. So they really liked the approach, and they said, fine, go ahead and deploy it in second site also. So that's the fastest decision-making I have seen in this kind of community based on, and we benefited from, again, Open RAN, because this is a lot more like traditional software development, generic servers, operating system, Linux, as opposed to highly sophisticated cellular devices and very few companies providing them. So a lot of people were familiar with these technologies. So that's, again, Open RAN is helping us from that perspective. And then we finished our factory test in December. And in March, we did the ribbon cutting and the network got deployed. So we have passed several months of data, and we have independent testing for data rates and latency and coverage and so on. We had a bit of a challenge because I said that we have both coverage, we have flight line, and also hangars. And hangars have planes, and planes are used of metal. So there is a lot of careful analysis you have to do to make sure that independent of the presence of planes, you have coverage inside the hangar. And hangars typically have metal walls, steel doors. So simple thing like you do your test when the doors are open, entirely different result when the doors are closed. So all those things were sort of eye-opening because you just take it for granted. Most of the houses in the US, they are made of wood and gypsum. So this kind of issue is generally not seen, but you see it when you go to a factory or a flight line operation. So this is a little bit more detailed view. So we use both middle band, CBRS, and N71, 650, around 650 for coverage. So the combination made perfect sense. And again, a customer wanted to use the network, not to design the network. They wanted us to design the network. So even though millimeter wave was in the proposal discussion, we are not using millimeter wave, even though our architecture design, it accommodates millimeter wave. And the reason is, again, is the combination of capacity density and coverage. So these kinds of things can be found only when you are interacting with the customer on a bi-weekly basis and doing a demo every month so that we can evolve the right architecture. And being software-driven, Open RAN helps us a lot. So that's, again, I mean, I'm repeating myself, but that definitely is a big component and that why we selected Open RAN and how it has benefited us. So when you look at the design, detailed design of this system, it looks a lot more like an IT system. There are a lot of routers, switches, firewalls, servers, and then you try to find, well, where's the radio? Then you would see a small unit radio, and of course there's an antenna, and which you typically don't put on a rack. But other than those antennas and radio units, everything looks like an IT application. So this is, again, an eye-opening thing for many companies because people think about cellular industry, telco industry, and they think of highly sophisticated, hence expensive hardware, and you don't change them often. And here we are adding features, we are fixing things remotely because it's mostly software-based. But it also required very detailed, very careful layer 2 and layer 3 design. And this was needed from security perspective. So management plane, control plane, data plane, user plane, they're all very distinct and very carefully managed. We have umpteen number of firewalls, internal firewall, external firewall, because we have zero trust architecture. So we authenticate every element, whether it's a software entity, hardware item, human being, and we have role-based access control. So zero trust architecture is an inherent part of Open RAN. And again, we injected it because customer sort of said that, hey, look at ZTA, because a lot of people are talking about it. So the combination of ZTA, and there is another thing, framework called Commercial Solution for Classified, CSFC. So that provides a very good posture with respect to security, and we benefit from that. So ultimately, we ended up with 3 racks, and these are sparsely populated because we absolutely believe that with this agile approach, customer will keep liking the network and will keep expanding. There are many more hangars in that air station. So you can see that in lower right, that we have a lot of space to expand. And most of the expansion would be just more servers and perhaps maybe 1 or 2 switches, but mostly servers will be getting added. So as I said that even though it's a small deployment, all the requirements, manageability, features, functions, it's all there. It has to be managed. We don't have hundreds and thousands of operators there. There are only hundreds of probably users. So we had to create a very automated management functionality. So we took our own management function, which we have used for 30 years. Of course, it's not that old. It has modern tools. As a capability, it has existed. And we scaled it down so that it can run on a server. And we run it remotely, but the way we have designed it, that eventually, if the customer wants, they can run it. And that's a big statement. Running a cellular network is not easy. I mean, I have not run cellular network until this thing went live, but I have run satellite networks and satellite networks based on cellular standards. So I know the complexity and the number of people you need and so on. We have to pay a lot of attention to manageability. And I think one speaker from Sprint talked about there's no northbound interface on Open RAN standards collection. I would suggest, support, recommend that let's add that. It's very important to have manageability. Otherwise, private networks, they will continue to be complex and very difficult to operate, hence expensive. So management is key. So security, there are a variety of tools available, things like Nessus, Splunk, and Cisco has a tool, SNA, it was called Stealth Watch. So we essentially created a deployed SOC also. So SOC doesn't mean that it has to run in a room, big room with tens of operators. We again put it on a server, scaled it down so that we can monitor, we can do vulnerability analysis, and we can do certifications, all that within that canonical 5G complete system, which is fully owned by the customer, so that the customer controls what software is added, when it is added, and how it is run, who runs it. So they have fully contained, standalone in traditional English sense also, implementation. So another thing which I said that besides zero trust architecture, ZTA, which requires authentication and encryption everywhere between elements, there's another framework which comes from the agency responsible for these kind of security architectures in the US, and it's called CSFC. It essentially says that you can send very sensitive data over commercial networks if you select components from trusted partners. So they maintain a list, and of course, this is a US-based implementation, and Cisco's and Juniper's and Dell's, they have multiple models which are available from that list. So once you select those models and go through the due diligence and show that how you have carefully configured them, then it's a lot easier to run sensitive data also. And the certification is a more straightforward process. So that also is an integral part of our design, and we have implemented that. So the combination of CSFC and ZTA, I believe, has gone very far in security. And again, no one can say that you have bulletproof 100% type security, but we have done detailed analysis. So there are 800-53, 800-171, various NIST models. So we have selected the appropriate subset and we have done the due diligence with respect to the security monitoring functions and how they have been implemented. So this is just another sort of eye candy view of various tools. They're nicely integrated, scaled down, so that they are running in this 3-rack configuration for a base. And this base is in the Northwest. It's about 2 hours from Seattle. Very nice area. I would recommend, if you happen to be in Seattle, please either drive. It takes about 2.5 hours, or take a ferry. Wonderful drive. And you can see the terrain also. It's a little bit hilly. There's a lot of water, but again, a very important area. So we feel proud that we are providing connectivity for this critical application. So again, this is probably my second to last chart. So Agile Development helped. And who would put agility right next to cellular? No one. Cellular used to do upgrades probably every 5 years, if not every 5 years, every 2 years. Here we are talking about developing features in 2 weeks, showing to the customer every month. So that is now possible because of the software nature of these implementations. And this is very important because future is all agility. It's AI enhanced improvements, energy improvements, efficiency improvements. So software will get upgraded, and no one will wait for 6 months even. People want the result immediately, which means in weeks, maybe in days. So agility helped. And as I said, that we finished our testing in December, and the system got launched. And we involved a third party, a very reputed third party, to do independent testing for coverage. So they drove around, and it's very difficult to drive when jet fighters are landing and big military planes are landing. So you need to get a special permission and make sure that you can go to the hangar, outside the hangar, do all the measurements, both from technical perspective, raw physical measurements, and also end user experience, quality of experience type measurements. So we did all that, no surprises. So from end-to-end perspective, everything worked very well. And as we designed, and again, we had the benefit of working with the customers. There were no surprises. Of course, we had a lot of hiccups. The biggest hiccup was we could not find equipment. We could not find simple things like routers and switches, sometimes even servers, because of COVID. So that was the biggest factor. But ultimately, we were able to reach the deadline because a lot of things worked very well. So we had, suppose, 3 months for some testing. It happened in 2 weeks. So we were able to recover from that supply chain issue very well. So in my last chart, so I had presented some challenges. So that with Open RAN, interoperability, I think we would see probably more interoperability. We have 2 radio vendors and works. We have 1 core. We are now trying another core, just plug and play. So I think we would see more. I think good work has happened in the lab. I think more is to be seen. And I'm going to meet again. Of course, we are working closely with Dish, our sister company. So I have a meeting with them. So I would learn a little bit more on the macro consumer side, how the interoperability is panning out. Because Dish, of course, has many more radios in their commercial network. Performance and scalability, it is not an issue for small networks. So I know that it's a huge issue for large networks. So it's a tricky thing. From my perspective, I see second tier, third tier performance optimization. I think no ROI. But again, it's a big issue for larger networks. Security, it's a major challenge for all of us. I believe the combination of ZTA and CSFC, it goes quite far. It goes quite far in community where people are a lot more security conscious. So that this is a good data point, and I definitely would look a little bit more into the working group, security working group, and see, I guess, where they are and how to inject this information. Synchronization and latency, we spent most of the time here. So people talk about distance between RE and DU. It does make sense to be careful about that. Orchestration and management is a work in progress, and a lot more would happen. And again, for larger network, it's a more complex thing. For smaller networks, you can optimize, but if you can optimize away 1 server out of 5, it's not a big deal. But 100 servers out of 500 servers, that may be a big deal. So I would end my talk. Thank you again, everyone, by making a request that sometimes it's the time to market, which is very critical. So the Open RAN community, I think we probably need a little bit more coherence. As an outsider, because I'm not heavily involved in the standardization, I see camps. And I think we have to bridge those silos. Otherwise, it'll be more difficult to use this set of standards and expediency. Definitely, timing is everything. People are not going to wait. People are building their networks, and they will find the best equipment and use them to meet their needs. Thank you very much for the time, and thank you, Ashutosh.
Thank you, Rajeev. Let's give a big hand to Rajeev.